हेलो गाइस, आज हम एक बहुत ही इंटरेस्टिंग और रेयर कंपाउंड के बारे में बात करेंगे, साइक्लोब्यूटाडाइन। नाम थोड़ा स्केरी लगता है, लेकिन मैं आपको आसान तरीके से समझाऊंगा। साइक्लोब्यूटाडाइन यानी C4H4। यू कैन ऑल्सो ड्रॉ इट्स स्ट्रक्चर। इट इज द साइक्लोब्यूटाडाइन। एक छोटा सा 4 मेंबर रिंग, लेकिन यह मॉलिक्यूल बहुत ही अनस्टेबल है। इसको नॉर्मल कंडीशन में नहीं पकड़ सकते, सिर्फ स्पेशल टेक्निक से स्टडी कर सकते हैं, जिसे कहते हैं मैट्रिक्स आइसोलेशन। इन द नेक्स्ट क्वेश्चन इज, क्या ये स्क्वायर होता है? जब हम इसके स्ट्रक्चर को देखते हैं तो लगता है ये स्क्वायर है, पर नहीं, ये एक्चुअल एक रेक्टेंगल होता है। 2 बॉन्ड्स आर सोर्स which are डबल बॉन्ड्स एंड उनका बॉन्ड लेंथ अप्रोक्स 1.35 एंगस्ट्रॉन होता है। इस बॉन्ड लेंथ के बारे में बात कर रहा था। And remaining 2 bonds are comparatively longer, which are single bonds. You can see here this bond and this bond. And उनका bond length approx 1.57 एंगस्ट्रॉन होता है। हक्कल मोलिकुलर ऑर्बिटल थ्योरी जो हम क्वांटम केमिस्ट्री में पढ़े हैं, उसके हिसाब से हम जब सेकुलर डिटर्मिनेंट सॉल्व करते हैं तो डीलोकलाइजेशन एनर्जी 0 मिलती है। इसका मतलब है कि साइक्लोब्यूटाडाइन में पाई इलेक्ट्रॉन्स डीलोकलाइज नहीं करते। इस वजह से सारे 4 बॉन्ड्स इक्वल नहीं होते। दैट्स व्हाई देयर आर 2 डिफरेंट काइंड्स ऑफ बॉन्ड एग्जिस्ट। लेकिन बेंजीन में पाई इलेक्ट्रॉन्स डीलोकलाइजेशन होता है, इसलिए उसके सारे 6 बॉन्ड्स इक्वल होते हैं, जैसे कि आप देख सकते हो। Here the delocalization is done throughout the ring. That's why all those 6 bonds have equal bond strength and also equal bond length. साइक्लोब्यूटाडाइन एरोमेटिक है या एंटी एरोमेटिक? एरोमेटिक होने के लिए 4 रूल होते हैं। It can be easily remembered by CCPP rule. C for cyclic, C for complete conjugation, P for planar and P for pi electrons, which must be 4n plus 2 number of. In cyclobutadiene, you can see it is cyclic. That's why first condition is yes, satisfied. But second condition is planar. Yes, it is planar. How can you know whether a compound is planar or not? If the hybridization is sp or sp2, then that would be a planar structure. As here all carbon atoms are sp2 hybridized. That's why cyclobutadiene is also a planar structure. Okay, it is not valid always, like in cyclooctatetraene. You can see the structure, every single carbon is sp2 hybridized, but still that has a tub shape. But generally this trick is valid. Whenever an atom is sp or sp2 hybridized, then it gives a compound which has a planar structure. Okay, then move to the third point, which is complete conjugation. Yes, there is complete conjugation. Pi bond can go here, and this pi bond can go here. So complete conjugation is also there. That's why first all 3 conditions is satisfied by cyclobutadiene. But the fourth condition, for aromatic compound, it must have 6 electron or 10 electrons. How do I know? Just put n equals to 1. Then what happens? 4 into 1 plus 2, 6 electron. 4 into 2 plus 2, 10 electron, like that. Just increase by 4. 6, 10, 14, 18, like that. But here only 4 electrons are there. 6 electrons is not present here. That's why it doesn't satisfy the fourth condition. So it is not an aromatic compound. Rather, it satisfies first 3 conditions and having 4n electrons. It means it is an anti-aromatic compound, and it is highly unstable and reactive. And next question is, why is it so unstable? पहले सोचते थे कि साइक्लोब्यूटाडाइन अनस्टेबल है सिर्फ एंगल स्ट्रेंथ की वजह से, क्योंकि इन 4 मेंबर रिंग द एंगल इज 90 डिग्री, बट इन आइडियल टेट्राहेड्रल स्ट्रक्चर द एंगल इज 109.5 डिग्री. सो 90 डिग्री इज मच स्मॉलर देन द 109.5 डिग्री. दैट्स व्हाई एंगल स्ट्रेंथ इज देयर इन साइक्लोब्यूटाडाइन. लेकिन यह पूरी सच्चाई नहीं है. साइक्लोब्यूटाडाइन का मेन रीजन फॉर इनस्टेबिलिटी है एंटीएरोमेटिसिटी. ओके, अदरवाइज साइक्लोप्रोपेन would also be unstable like cyclobutadiene, but still when you compare the stability, you can find it would be more stable than cyclobutadiene, okay, due to anti-aromaticity of this compound. Let's talk about cyclobutadiene's reactivity. किस हालत में क्या करता है? There are different conditions, and on that condition it will behave differently. Okay, first case is at low temperature under 35 Kelvin. Here matrix isolation can be done and is 35 Kelvin में ये खुद में stable होता है. So the matrix isolation process is done generally at low temperature so that it exists as itself and researcher can do research on its reactivity. And the next condition is how does it react when trapping agent is present. In the presence of trapping agent, it do Diels-Alder reaction. Let's see how does it occur. Here are some example of Diels-Alder reaction. So may you know, in Diels-Alder reaction there are two main things. One is diene, another one is dienophile. Sometimes it can act as a diene and sometimes it act as a dienophile. Let's see how does it act as diene as well as a dienophile. Let's consider this reaction. Here this cyclopentadiene acts as a diene, but it will act as a dienophile. Okay, let's see how this reaction occurs. We can also represent cyclopentadiene as this. Those structures are equivalent. And now the cyclobutadiene is here. Those two pi bonds react with this pi bond and forms a product molecule like this. It is an endo product. How the concerted step can be shown? This pi bond goes here, this pi bond goes here, and this pi bond goes here, so that we can get sigma bond as this position, another sigma bond as this position, and this pi bond and another pi bond as this position. Okay, this is how the product molecule is formed. And as the ring is present downside, that's why it is called endo product. If it would be at upside, then it would be an exa product. Okay, in this first case cyclobutadiene acted as dienophile. Let's see, does it act as a diene? Yes. In second example, you can see cyclobutadiene is here and this compound is here, and here how can we understand the reaction? Just shift the double bond. This pi bond shifts here, this pi bond shifts here and becomes sigma bond, and this pi bond turns into sigma bond. Two pi bonds turns into sigma bond, another pi bond remains as a pi bond, but the position is changed. That's why we can draw the product molecule. We can see the product molecule here. And the next one is how does cyclobutadiene acts in presence of electron pushing group and electron pulling group. Here the cyclobutadiene exists as itself due to resonance. Let's see how does it happen. Here is the example where two electron pushing group is substituted in cyclobutadiene. Also two electron pulling groups are there. You can see the resonance can occur. How? Let's see. In nitrogen there are lone pair. In two nitrogen, two lone pairs are there. So those lone pair goes into delocalization, and this pi electron can go here, and this is how we get a resonance structure. So due to resonance, cyclobutadiene exists as itself. Just remember that chart which is already given. Just by remembering this chart, we can remember all the different conditions and existence of cyclobutadiene. This chart is very, very important. And let's talk about another condition. What happens when alkyl substitution is done? Let's see what happens when alkyl substitution is done. Here is the example when those three positions are substituted by tert-butyl group. Okay, due to hindrance, those molecules can't comes closer. That's why no dimerization reaction happens when those alkyl substitution is done, because tert-butyl group means very, very hindered group and it is more bulky. That's why no dimerization occurs. What is dimerization? Let's see. If nothing is given, or like no trapping agent is given, no electron pushing group pulling group is given, or substitution is not done, or hemicarcerand ring is not given, it would be R. not can, that is carcerand. Okay, hemicarcerand ring is not given, then dimerization occur. What is dimerization? You can see in next slide. Here is the dimerization reaction. What happens in dimerization reaction? One of the cyclobutadiene acts as a diene and another one acts as a dienophile. Here, thus just consider this ring to be diene and this rings to be dienophile. This pi bond goes here, this pi bond goes here, and this pi bond goes here. This is how we can get another compound, and it is already drawn the product molecule here. To just draw the structure, those two pi bonds are converted into sigma bond, first sigma bond, second sigma bond, and this pi bond is converted into next pi bond. Okay, two pi bond converted into two sigma bond, and remaining one pi bond converted into again another pi bond, but the position is different. Okay, let's see another condition. What happens if any hemicarcerand is given? Then cyclobutadiene is trapped within its cavity. Let's see how does it occur. It is the hemicarcerand ring. Here you can see within this ring a cavity is there. I've forgotten to mention that this tetra-tert butyl cyclobutadiene ring, not this. If another tert butyl group is substituted here, then this compound is stable up to 150 degrees Celsius, but it is highly reactive when oxygen is present due to its high energy of HOMO. Okay, but generally in the absence of oxygen it is more stable up to at least 150 degrees Celsius. Let's talk about di-deuterocyclobutadiene. What is di-deuterocyclobutadiene? Di-deuterocyclobutadiene is this. If two hydrogen are substituted, and then we can get di-deuterocyclobutadiene. This one is di-deuterocyclobutadiene and this one is also di-deuterocyclobutadiene. Are those two structures same? No, there are two different isomeric form. It is first isomeric form and this is second isomeric form. But why are not those two same? Because those pi bond here, those two deuterium atom is substituted along a double bond, but here those two deuterium present at different position. Means it is first deuterium is attached to another one double bond and second deuterium is attached to another double bond. That's why those are not same. Even you can't get delocalization here. That's why those are not resonating structure. Even those are isomeric forms, but those can easily be interconverted to each other and cannot be isolated, because those were not the product molecule or reactant molecule. Even those were intermediate, because cyclobutadiene is not stable. Even 1,2-di-deuterocyclobutadiene is also not stable. अगर आपको ये वीडियो हेल्पफुल लगा हो तो लाइक करें, सब्सक्राइब करें और नीचे कमेंट करके बताएं कि और कौन से टॉपिक चाहिए. केमिस्ट्री को आसान बनाते रहिए. मिलते हैं नेक्स्ट वीडियो में. तब तक के लिए बाय.